In this video, you will learn how to write equations for the formation of both polychloroethene and polypropene, as well as uses for both of these polymers. It is recommended that you watch our video on polyethene to give you more of a background on addition polymers before watching this video. Let us start by quickly reviewing the polymerization of ethene. Here is an ethene molecule in a row, and under high pressure the double bonds break and the remaining molecules attach in series to form a long chained polymer. To write this in equation, we would show this, where n represents a large number of molecules and the square bracket shows the repeating unit. Here is the molecule chloroethene. Based on what we have recapped, pause the video now and try and write an equation for the polymerization of chloroethene. Here are chloroethene molecules in a row. Now let us break the double bond and join these molecules together to form a polymer. Writing this as an equation, we must show n molecules of chloroethene and the repeat unit of the polymer as shown. Polychloroethene is a very commonly used polymer, and it is likely you will have heard of it by its old name PVC, polyvinyl chloride. It is used in plastic PVC windows and doors, and it is also used in pipes, signs, and even in clothing. Polypropene is our next polymer. Pause the video now and draw the structure of the monomer for polypropene. Some of you may even wish to attempt the equation for the polymerization of this molecule. Hopefully, you will have drawn propene as the monomer. Although the actual shape of this molecule looks like this, when drawing polymers, it is much better to think of the molecule in this shape. Exactly the same process occurs. The double bond breaks and the polypropene is formed. Here is the equation for this reaction. Polypropene is strong and is also resistant to fatigue, which makes it extremely useful for plastic hinges such as those on drinks bottles. Polypropene is also quite resistant to temperature, and therefore it is often used in medical equipment that needs to be autoclaved, and also kitchenware that may be put in a dishwasher. It is also used to make pipes, containers and bottles. Now, at the end of this video, you should be able to write an equation for both the formation of polychloroethene and the formation of polypropene, as well as name uses for both of these polymers.